There have always been limits to how much we can learn from crash test dummies. They have become more biofidelic over time, but they're still only surrogates for real vehicle occupants. And the underlying data that correlates the forces the dummies record to the risk of injury for a real person was developed decades ago from a relatively small segment of the population. As researchers collect more information on how different types of people respond to crash forces, the opportunity now exists to move beyond the limitations of one or two dummies in one crash test. Computer simulations, or computational modeling, allow us to change specific parameters in a test, and in the future will help us predict crash outcomes for all of us. To learn a little more about these developments, Linda and Griff have a few questions for me.
You're getting so much data from various sources now. Is it possible to start using computational models to actually enhance the crash test dummy experience to determine, well, this could happen in older individuals or in younger individuals or different body shapes?
So computational modeling holds great promise for being able to look across the variability of the occupant population or even different types of crashes. Remember, we're doing one crash test that needs to represent, for example, all the side impacts out there for our side impact test, and it doesn't. Different things happen in crashes, and with computational modeling, we can look at many more variables.
So do you see a point at which you wouldn't have to create a crash test dummy that represented a 65-year-old woman with osteoporosis, but you could maybe use computational modeling to look at your crash data?
That is a great example of a situation we hope to be able to do in the future. Collect more data to understand how to improve our models so that we can best represent that older female occupant, and then be able to run computational simulations and get even richer information than we could get from an older crash test dummy.
Right. So you could do one crash and imagine if you had good models, all the other extrapolations you could run to apply to a much broader population. You don't have to do a test with every single type of dummy.
And that is really what we're working towards, because dummy development takes a long time. The dummies themselves have limitations. They will always have limitations. Right. Computational modeling offers the opportunity to explore many more factors.
Right, but it sounds like you'll still always need the physical crash test to build off of.
We will always need the physical crash test. We think about modeling as a supplement to physical testing, that you need to anchor those computational models in physical testing.
Right.
But the promise is that you can, one, do things that you can't do with a physical test,
Right.
and you can also do many, many more simulations than tests you can run. But a really important thing to remember is, just like our physical dummies, our computational models still need all of that validation data, all of that data to make sure we understand that those models are performing in the same way they would in a physical test.
Right, but you have to start with good data.
Yes, I think the favorite phrase they use in the computational modeling world is garbage in, garbage out.
Right.
So if you don't have good data coming in, then you're not going to get good data coming out.